Okay, another example of a function, for graphing a function. F of x equals x plus sine x. So if we take the derivative, derivative of x is 1, and derivative of cosine is cosine. We have 1 plus cosine of x. And this is going to be 0 if x is a cosine x is negative 1, which would be at the odd multiples of pi. So let's say cosine of let's say minus pi. Cosine minus pi is negative 1, and negative 1 plus 1 is 0. Cosine of positive pi is negative 1. We'll get 0 there. Cosine of 3 pi, negative 1. Negative 1 plus 1 is 0. So the derivative is 0 at those points. If we pick points in between, let's say negative 2 pi, the cosine of negative 2 pi is 1. 1 plus 1 is 2, so that's going to be positive. Cosine of 0 is 1, so that'll be positive. Cosine of let's say 2 pi is 1, that's going to be positive. 1 plus 1 is positive, and so forth. So so this it's not going to have local extremes. It's increasing, then slope 0, and then increasing again. It never switches from increasing to decreasing. So if we take the second derivative, the derivative of the derivative, derivative 1 is 0, so it's just the derivative of the cosine, which is minus the sine of x. So sine is going to be 0 at multiples of pi. Okay, so it's going to be 0 at my cosine is okay. Okay, so it's going to be 0 at all multiples of pi. So it's say minus pi and 0 pi 2 pi and so the sine is 0 at all these places. And if we pick some points in between, let's say negative 3 pi over 2. Sine of negative 3 pi over 2 is going to be 1, but we want minus the sign, so that's going to be negative. Negative pi over 2, the sine of negative pi over 2 is negative 1, but we want the opposite sign, so that'll be positive. And the sine of pi over 2 is 1. We want the opposite sign, so this will be negative, and so forth. It's going to alternate. So we have concave down, concave up, concave down, concave up, concave down. And we have inflection points at multiples of pi. Okay, so okay, so then we take a look at the intercepts. The intercepts occur when the y-intercept occurs when f of 0 equals 0, which would be at 0. And it's also an x-intercept. And if we try to get other x-intercepts, we want to solve x plus sine x equals 0, which means that sine of x is equal to minus x. And you can see from the graph that the only place that the graph of minus x intersects the graph of sine x is at 0. So the only x-intercept is x equals 0. And then you can just plot some points and sketch the graph. Okay. This is I just plug in some points and sketch the graph, and we can see that in no place does it have negative slope. That the slope is either positive or 0. So it's positive slope, and that flattens out, and it's positive slope again, and flattens out, and positive slope. And the concavity switches. Here it's concave. It spills water, holds water, spills water, holds water, and so forth. The concavity also kind of switches. And this sort of verifies that. Okay, so that concludes this presentation.